Hi, and welcome back to Programming Robotic Systems with Visual Studio. I'm Paul Party. I'm here with Chris Howd, and we've been walking you through building these small robots and then programming them using the tools of Visual Studio. So we're going to jump right back in. We're going to actually start Module 3 by looking at how to build an actual Arduino robot using the Arduino boards. And we're going to walk you through the components of building this robot. So
we'll be doing the MS BugBot,
that's right,
that we demoed earlier.
You can see that guy right here. We showed this in Module 1. We just gave a quick demo of how he works. And we're going to show you the components of how to put them together and then do the programming so that he can actually walk around and bump into things. So as we get into this module, there's some things obviously that you want to consider as you're building this robot. The one thing that we did is we started, what did we want the robot to do?
Right.
So
always figure that, right? That's going to define your hardware. So it's like, what do you want this thing to do? Do you want it to climb upstairs? Do you want it to make coffee? Do you want it to wander around bumping into stuff and changing direction?
That's right.
We picked one of those. Then, you figure out what you want. Then you start working on your hardware list. You can pick your controller. You got to think about cost, though, right, Paul? This is, everybody has to think about cost, right? You could have a lot of money, you still should be thinking about your budget. And then you go through, you're going to need shields, you're going to need this, you're going to need that. What are your materials going to be? What do you have the tools that you'll need to make the parts? Those are the kinds of things you need to consider.
Yeah, so then that's just all goes into the design of the robot, what you need to do to get the robot to do what you want it to do. So we're gonna talk a little bit about that. We'll look at the hardware itself and show you a demo of how the hardware works. We have a little kind of test bench here, which will show you how things are put together. We're going to do some diagnostics. So as you'll see, there's some complexity in making sure that the wheels are calibrated properly and that the bump sensors work and all the rest of it. So we'll show you how we put those together using kind of these incremental test benches, and we'll walk you through them. And we'll do 3 different demos, and then we'll pull it all together at the end and show you how it works in an integrated way in our MS BumpBot. So that's what the module is going to look like. All right, so when you consider your design requirements, Chris and I were just talking about that a little bit. Again, what do you want it to do? What are your budget constraints? What hardware will you need? One thing we didn't talk about earlier was tools. So you're going to obviously need a bunch of tools to put these things together. The robots that we're showing you aren't terribly complex in terms of needing a lot of tools, but you will need certain things. Chris will talk about that as he talks about the assembly of these robots. One of the things that we actually used pretty heavily was a 3D printer, which is not on everybody's workbench, but it does help if you're needing to make a part. The robots that we're using use plexiglass mainly, so that's how we built the frame and the legs of the actually the legs of the spider aren't plexiglass. But Chris will talk about the materials there. But there's lots of materials you can use. Yeah. A 3D printer allows you to kind of put those things together.
The main thing is think about what you're trying to achieve, pick your materials within your budget. And don't overdo it. Don't overthink it.
That's right. All right, so let's just jump right into the BugBot device itself. We'll look at the MS BugBot hardware.
All right, sure. Okay, so we picked plexiglass. One of the reasons really was that we wanted to be able to see the parts through it for this series, right? So then we're using continuous rotation servo motors. We've already seen how to use those. It's pretty reasonable cost. And then we just use these wheels, right? You could get wheels that attach. That was pretty cheap too, and they have a caster in the front. For our electronics, we have an Arduino Uno board. We have the bump sensor switches, and then we have some wire and some glue and some different things like that. We have a nickel metal hydride battery, and we actually have 2 of them. But that's it. That's our materials. Short and sweet.
All right, let's talk about some of the specifics in actually putting this thing together.
Right. Okay. So now we've seen how we have one wheel and we can turn it forward and backwards. Might have seen a little bit. I can't remember, Paul. Did we see that servo kind of turn in a little bit?
We
talked about the center speed. So you want to, now that we have 2 wheels, we want them balanced in their speed, right? Because if it's not balanced, it's going to turn at a funny angle, right? It's going to go. It's going to go in arc instead of straight. We did. We saw that was not calibrated correctly. So what do we want to do? We need to balance those. We're going to go forward a little bit faster, and we're going to go backwards. That's a personal choice. we need to be able to control the motors independently. So we want to balance the speed, but we also want to be able to have one wheel going faster than the other so that it does turn, or we could make one wheel go backwards while the other is going forward so that it spins in a circle, right? So those are the kinds of things we want with our wheels. Code structure, right? We already looked at a little bit of that too, Paul. When we were building our other routine, we separated out the function for wheel speed into its own routine.
That's right.
We're going to do that kind of thing again. What we'll do is we'll control our wheels with their functions, and then we'll think about the robot as an abstraction layer above that, right? So we'll say, okay, we're going to use these wheels, but if we want to spin the robot counterclockwise, we'll have a function for that, and then we'll call the wheel speeds from there. So we'll send one wheel in reverse and one wheel forward if we want it to spin.
That's right.
Flip it around if we want to spin the other way. Same for forward and reverse. So we'll think about our robot as an entity, and we'll use these little functions calls to control it.
Great. All right, let's switch to the demo then, and we'll talk about using the diagnostics tools to manage wheel speed.
All right, so here we are in Visual Studio, and we have this already set up a little bit here for us. We have two servo motors, right? Two servo objects. We've already got our libraries set up.
And again, we looked at how to do that in Module 2.
We did.
So we're using essentially the same servo library, and then we have a wire library as well.
Right. So we have an integer for the servo control pin for the left servo and the right servo. We have the speed left forward and right forward, back, and stop. So we have our different speeds set up. We're going to have a little Boolean here that tells us whether it's in diagnostics mode, because as you're working on your robots, it's nice to have a diagnostics mode that you can go into rather than have it go into their live robot mode. That way you can check out your stuff, your wheel speeds, and get those all calibrated in a routine. You can leave it there because you might need it again, and then you have it and you can work in that area. Right? It's just a good practice to be in.
That's right.
So we have, back to the code, we have a Boolean for that, and then we go into setup. All right. Well, we got our pin settings, and then we're attaching our motors. This is all the same stuff that we did before. Now we have our speeds, right? You can see we're saying our forward speed is a little bit bigger, about twice as big as our backward speed like we wanted. And we set diagnostics mode to true, so we're going to go straight in. Over here, you can see some comments. See, I ran this code before. To get these balanced out, we're actually going to have to tweak one value up. The left servo will tweak that speed up to 109, and then we keep the other at 100. And then for the reverse speed, the other one is going up. That was the experience that I had when I wrote this the first time. These things drift a little bit in their values, so we might see something a little bit different. Then we have our loop, right? And we have it set up here so that we can stop the robot, we can run it forward, and we can run it backwards. And then down here, we're controlling our wheels independently, and we'll be calling those routines, right? And then here's forward, backward, and stop. All right, so that is the code. Let's go ahead and run this. We're going to say stop first, just to see what it's looking like. That's where we'll balance them, right?
Sure.
Because when it's stopped, they should both be stopped. And we'll see if one of them's turning or both of them are turning a little bit. We're kind of expecting, I don't remember. I think I must have balanced these out because we didn't say adjust one of the 1500s. But let's see what happens. All right. Let's see where we are. And we'll say debug. And we'll start without debugging. Are we connected, Paul?
We are plugged in.
All right. Let's see what we get. We're uploading. Done uploading. And guess what? You need to turn the power on these things, oddly enough. Okay, so we're actually seeing both of them turn a little bit in opposite directions. Mm-hmm. Paul, you know what? I am going to say that's okay with me for right now.
Okay.
We could go up here. Well, we'll do it real quick. We'll just try and adjust one of these. We'll say that this one, we're going to say, is 1490. We'll see whether it goes the right way or not.
So those are supposed to be in stop position.
We'll see. We'll switch back now to the little guy. Oh, we got him going there. Let's go ahead and say, run that again. Yes, it should be stopped, and we'll see whether one of them actually speeds up or whether it stops.
Oh, there we go. A little closer.
So anyways, that's the idea of what you do, right? You adjust that. We could adjust it in hardware. We talked about this before. These servo motors have a little spot on them. This guy's probably blocked off. I'm gonna tip it up towards the camera, and you'll see it, the little areas. So do we have a good enough view to see those two little holes? I don't know, maybe not. But there's a little hole right here. There's a screw in there. There's a potentiometer, and you can adjust your zero position. That's good enough. So one of them seems to have stopped. We adjusted that correctly. You used the same technique for the other one. But we're going to keep moving here. And we're going to say, OK, stop. Fine. We kind of get that. Let's check forward. And again, right, we want the speeds to balance. So we're going to say, I'm going to do a Control F5. That's same thing as using the menu for run without debugging. Now they're moving. Well, we have one end that's a little bit silvery. Looks like maybe one of them is catching up to the other one and passing. It's a little bit faster. Let's just go up real quick. Let's try and see if it stayed at that value. We're going to put in a 109 there. I would think about adjusting that 0.2 back to 1500.
Yeah.
Just in case, but I'm not going to do it. We'll just try it because I think I had them both stopped before. We're going to rerun this, Control F5. It's going to upload the program. Now it has the new value in it. And maybe they're in better sync. I can't really tell for sure.
A little bit better, yeah.
But you kind of get the idea, right? That's the way we do that. It's good to have them balanced because now, right, if they're close, at least it'll go pretty straight.
That's right.
And that's what we're trying to achieve. And you do the same thing for reversed, and then once you've gotten that done, you're done with your calibration piece, right? And you can do it for different speeds too. If you need your robot to be running at a bunch of different speeds, then you can calibrate the wheels for each of those speeds, and you'll be all set, and you can go forward and nice and straight at all these different speeds.
Does the cost of the motor improve or decrease the calibration and the ability of the motor to operate in sync with another motor? Have you noticed that?
You know, Paul, with these servo motors, I've purchased a few different brands of continuous rotation servos, and I think they all need a little bit of adjustment.
Yep.
But they're also relatively expensive. I haven't purchased ones that are super expensive.
Sure.
So those I would expect are probably going to be a little bit better behaved.
Yeah.
But I think I've run this, Paul, and maybe we switched directions.
Yes, we have.
So there was an adjustment indicated up here that we could switch this value up a little bit. We'll try that. 65 here, and we'll rerun that again. It's going to stop while it's loading. It's going again. And now we should have them balanced in forward and reverse.
Yeah.
And that is how you do it.
Got it. Now, is that number applying to both motors? The right servo speed right, I see servo speed right and servo speed left, I see. So you have them separately.
So here's another thing we should point out, right? We've mounted these two servos so that the wheels are pointed outside the outside edge of the vehicle, right? So now they're in different orientations.
Yes.
So you can see we were saying plus to go in reverse on one, and it's because they're going the opposite directions, right, from their own orientation. Sure. So you do have to switch that around. It's just another thing to think about.
Yep.
But that does finish us up with this demo.
That's right. That's wheel speed diagnostics. So maybe we can...
I'm going to unplug this so we don't have to hear that.
Yep. All right, what we're going to do next is look at the bump sensor. So if you'll remember from the demo that we did in the first module, the little bump bot actually has bump sensors to indicate when it hits a wall. And when it detects that it has hit a wall, it will stop, and then it will reverse direction, spin a little bit, to try to get away from the wall. So the bump sensors is actually an indicator that the robot has on it, sends a signal to the board. The board then, you can have the program adjust to that signal that's being sent to the board. So we're going to show you how that works now.
All right.
So
we have a slide we're going to talk to here?
Right there.
All right, here we go. Sensors and pins, configure them. We've done a lot of that, Paul.
Sure.
We have. We've already done that. But basically, you just tell it what pin you're using. It's a digital pin because we're gonna read it. We hold it high. Remember how we did that? We did the digital write to hold it high. That uses the internal resistor on the Arduino board to hold it up high until it gets pulled to low, pulled to ground, right? Which the switch does.
And again, if you missed that or you're just joining us, check Module 2 out. We talk about all those things in Module 2 when we show you how to program that. So
yep.
Check that out.
All right, so Paul, all I need to do here, so we got this new little guy, right, here. And so he's got the servo in front. That servo's going to run until we touch one of these switches. That should momentarily stop that servo as we touch each one of these. We're wired up to 4 of the digital pins, grounded, and we have a wire for the servo and some power. So I am going to plug in the board to my PC so that we can upload that program. If this little guy, it looks like we're running off of the power of the power supply off the USB. So it's not, I wouldn't say that's a best practice for a servo, but we can get away with it here because we just have one and we're not going to pull too much power. All right, I am going to switch. I have another Visual Studio project open here. Let's look at the code a little bit of what we're doing. Again, we have the servo, so we needed that. Otherwise, for the switches, we don't need that. But we could have used a light, Paul, but in here it's hard to see the lights. So we're going to use a servo to see that the switches are working. We have a pin for each of the switches. So this is front left, to understand my code here. Front left, front right, back left, back right. And then we have a sensor value, because we're going to read the value off of the pin. And then we have a robot state, which, Paul, I don't remember what that is. We're going to have to see down lower in our code. Yeah. We have a servo pin, servo speed, and we say my servo again. The servo's on pin 11. We attach the servo like we did before. We set the speed at 200, and we do a write, and we start it moving right off the bat, right? So it's moving as soon as setup runs. Then we set the values on our pins, and we use pin mode to say they're inputs. We hold them high. All right, in our loop, we say robot state equals bump, read bump sensors. So our robot state comes back from our function, which is going to read those sensors. And then we're going to run the servo, and the servo is going to be running at the stop speed of 1500 plus the servo speed, which was 200, times robot state. So I'm thinking robot state is going to be a 0 or a 1, Paul.
Yeah, that's right.
I'm guessing. Let's see what we got. We got an int from read bump sensors. We read the values off each pin, right? They're held high, which is going to be a 1,
yep,
until they get pulled to ground, which is going to be 0. So we're looking at if the value of any of these sensors is low, return low, otherwise return high. So that's pretty.
Switch the direction of the motor.
Pretty simple. It's going to stop it.
Oh, stop it. Got it.
Right. If it gets a low, then it's going to return a 0. We're going to multiply.
Oh, that's right.
Right, by a 0, and so we should be stopped. All right. So we're plugged in there. Let's try to build and run this guy. Rebuild solution. All right. And it's built without an error, which is always a good sign, especially, when I'm writing this code. It's uploading, and okay. All right, so now it's turning. This is what we expected, right? We told it to, in setup, we told it to start turning. And we're holding these pins high. Go ahead and, and hold it. So as long as you're holding that, then it stops. And then the other pins would work the exact same way. I mean, if you can reach one here.
Go ahead and do it.
So each of these pins is wired apparently correctly. All right, so that's the whole deal there, right? We got each one of these things. So what we've done a little bit differently than last time, in our previous module, we talked about, we used a different kind of switch, right? It's a momentary switch. This is more like what we use in our MS BugBot, because when it bumps into a wall, as long as it's on that wall, that switch has a value, right? And we're going to do something. We pause, right? And then we back away, right? As soon as it backs off, that switch goes back, right? It's not permanently stuck there, right? Because otherwise it would stop all the time.
That's right.
It wouldn't need to run into anything. All right, so that's how that works, and that demo is also complete.
That's right. So now that's how you set up the sensors. Now what we're going to do is bring it all together and show you how both of these concepts, the wheel concepts that we showed you earlier and the sensor concepts, work together to form this MS BugBot robot. All right, so we'll pull it all together in code.
All right, so yeah, so we're pulling it all together in code. What does that mean? Well, right now we can read the switches, we can move the motors. But how do we decide to do anything, right? And that's what we're doing now.
That's right.
We're adding all that logic that says, okay, I want to be able to spin 360 degrees, or I want to spin, counterclockwise for half a second, or I want to do this, I want to do that. And if you write your code smart enough, right, then you won't get stuck in a corner, right? Because this guy's going to go into a spot, and it's going to try and back up. Basically, yes, right? But it needs to turn a certain way. So depending on which of the sensors is up against the wall, it's going to take that into account as it goes. It's also going to look at how much time has gone by since it's trying to maneuver out of that position. So if it's like it moves, it hits its front right side bumper, and it starts backing out a little bit to the right, and it hits its rear right side bumper, it's like, oh man, it thinks I'm in a corner. I need to figure out another way, and maybe it spins or does something. So those are the kinds of things you need to think about. We are going to move to the Studio B, to the pit, and we are going to look at that.
The BugBot on the loose.
All right, very good. Let's do it. Welcome back. Here we are in the pit. We are demoing the MS BugBot, and let's set it go. Going to turn this bad boy on, see which direction he chooses to go. I'm guessing kind of forward. Let's see how he does. All right. Now you can see he is turning a little bit as he goes, and that is because those servos are not balanced. We talked about that, but we did not fix it in our code as we should have. He's going to wait there for a second. He's going to say, all right, I need to back up. I've touched this servo, this sensor, and uh-oh. All right, we were talking about this just a minute ago. These walls are a little bit bouncy, and so if he runs into a position and gets a little bit of bounce back, the sensor releases. So we're going to try that again. And he should then back up, turning a little bit, and pick a new direction. He's going to go out here and makes contact with another wall. He's going to do the same kind of thing. He's going to say, all right, this time I ran into this. I'm going to move a little bit differently. He's moving backwards a little bit slower than he goes forward. And he's stuck in a loop. This code needs work. I expect all of you people out there building robots to do a better job than we did. All right, that is the MS BugBot. We will meet you back for Module 4.